Session 8.3, Testing a Claim about a mean. In these sessions, we're going to talk about how to perform the hypothesis testing about the population mean. We do have two parts in these sessions. First part, we're testing a claim about a population mean when we know about the population standard deviation. Just like the chapter 7, if they given the population standard deviation, we'll be using the t distribution. Okay, requirements. It has to be a simple random sample, and then either or both of these conditions is satisfied. Population is normally distributed or the sample size has to be greater than 30. And this is just like the chapter 6, the central limit theorem. Either the original population is normally distributed or the sample size is required greater than 30. So we could make sure that will be the normal distribution. Okay, notation. N is going to be your sample size, X bar will be the sample mean, and this is going to be the population mean. And because we applied the central limit theorem, so you're going to see the population mean, we do have the X bar in here. Okay, but by the central limit theorem, the population mean, it doesn't change. And then we have the test statistic. Okay, this is the formula for the test statistic. Before we talk about the hypothesis testing, we want to know how to find the p-values using the t distribution. Okay, remember when we have the z distribution, the normal distribution, we'll be using the normal CDF. Okay, normal means the normal distribution. And since when we are using the t distribution in these sessions, that will be the TCDF. The idea is similar to the z distributions. We always look at it, the numbers from the left to the right. Okay, from the left to the right. And then we have the lower value, upper value, and then you need to find the degree of freedom. Degree of freedom will be n minus 1 in here. Okay, let's look at the example. The first one, use technology to find the p-value for the hypothesis test described below. The claim is that the body temperature of healthy adults, the mean is strictly less than 97 Fahrenheit. The sample size is n equal to 10, and the test statistic is t equal to negative 1.877. So you're gonna see this is gonna be your original claim. Okay, the original claim statement is given. The mean strictly less than 97 Fahrenheit. So first, I want you guys write down the null hypothesis and the alternate hypothesis. Okay, the null hypothesis. You should have mean greater than or equal to 97 Fahrenheit. And alternate hypothesis should be strictly less than. And then you're gonna decide that will be left tail, right tail, or two tail. And since we have a strictly less than, so we have the left tail test here. Okay, now we're gonna sketch the picture. This is gonna be looks like the normal distribution with the left tail test. And then they're gonna given the test statistic negative 1.877. So that will be here. This point will be the t equal to negative 1.877. And this is gonna be the left area, the left tail area. And we need to find the p-value. P-value will be equal to the left tail area. Okay, this part will be the p-value. Okay, so now we'll be using the TCDF. Okay, TCDF. Make sure you always look at it from the left to the right. So the lower value here, that will be negative 1E99. And then the upper value will be negative 1877. And then you need to do the degree of freedom. Degree of freedom will be n minus 1. So it's going to be 10 minus 1. You're going to get a 9 here. So now I want you guys to use your calculator. Go to the second bars and then find the TCDF. Okay, you should find this value using your calculator. Okay, so example 2, I want you guys try to do it by yourself. Just like the previous example, write down the null and alternate hypothesis. And then decide it's going to be left tail, right tail, or two tail test. And then sketch the distribution and use the TCDF to find the p-value. Okay, let's try to work. Okay, this is gonna be the claim statement. Okay, this is the original claim. So you're gonna write down the null and alternate hypothesis. Okay, equal will be the null hypothesis. So alternate hypothesis is gonna be not equal to. And then we are working on two tail test. So two tail here. So we need to find the area of the left tail and the right tail. So they given the test statistic 1.749 here. Okay, so let's find the area of the right tail. The lower value will be 1.749, upper value 199. Degree of freedom is going to be 23 minus 1, so it's going to be 22. Okay, and remember, this part is only the area of the right tail. But right now, we do have a two tails, so we need to multiply by 2. You're going to get this number. Okay, so this is the way how we finding the p-value when we using the t-distribution. Performing a hypothesis test for a mean using the p-value method. So S is given. S is a sample standard deviation. Every time when you have a sample standard deviation given and you are working on the population mean, then we'll be using the t-distribution. Okay, the t-distribution. So we're gonna verify the requirement. And then we're gonna follow the step here. Okay, when you guys look at the questions, you're gonna see there's a p-value, means we are working on the p-value method. So first, when you guys with the claim statement, you have to decide which population parameter you're working on it. Are you working on the population proportion, population mean, population standard deviation, or population variance? Once you decide you're working on the population mean, read the question carefully as is given. So find the formula from the chart. Okay, the T here means like using the T distribution. So you have the test statistic formula here. For the extract information, you're gonna base on this formula. What do we need from here? We need the N, the sample size. We need the sample mean, so we have the sample mean here. We need the sample standard deviation. And also we need the population mean. You're gonna see this is a two different notation, but remember that this is talking about the central limit theorem. But the central limit theorem, we do have the same population mean. Okay, you could use this notation or you could use this notation. And then with the question, with the claim statement, find out your original claim. And then design your null and alternate hypothesis. Remember, null and alternate hypothesis is always a complementary. If this is equal, this guy has to be not equal to. If this is a less than or equal to, then this is going to be greater than. Okay? After you write down the null and alternate hypothesis, you're going to decide if you're working on not equal to, so that will be two tail. If you're working on the alternate hypothesis greater than, that will be right tail. Strictly less than, that will be left tail. Okay? Once you're done here, you could find all this information, plug into the formula to find your test statistic. And then, depending on your alternate hypothesis, I only show you guys the left tail example. Okay, let's say we are working on the left tail. So this is the T distribution. T distribution, it just looks like the bell shape, right? It's just more spread out. Then we have the left tail here. So we find the test statistic from the step 4 here. So this is gonna be my test statistic. And we need to find the p-value. P-value will be the area of your left tail. Okay, so when we want to find the p-value and we are using the T distribution, we'll be using the TCDF. Okay, TCDF. You could get this from your calculator. Second, VARS, you're gonna find your TCDF. Lower value, for my example here, that will be negative 1 in 99. Upper value, that will be your test statistic. Okay, make sure you always look at it from the left to the right. And then you need to find your degree of freedom. Degree of freedom will be n minus 1. Okay, sample size minus 1. So this is how we find the p-value. Again, this is the left tail example. If you are working on the two tails, okay, two tails, then you need to multiply by 2, okay, multiply by 2 if you have a two tail. After that, you're gonna use your p-value to compare with your significance level. Your alpha is given. If less than or equal to the alpha, we're gonna reject. Greater than the alpha, that will be fail to reject. Okay, then final words. Look at the chart in the section 8.1. We do have a number 1, 2, 3 conclusion. Okay, so this is how we perform a hypothesis testing for the population mean using the p-value method. This is the instruction how you can use the calculator to find out your test statistic and also the p-value. Okay, you could follow this instruction and try it for your example 1. Okay, example. In the manual on how to have a number 1 song, it is stated that a song must be no longer than 210 seconds. A simple random sample of 40 current hit songs result in a mean length of 234.6 seconds and a standard deviation of 57.54 seconds. Use a 0.05 significance level to test the claim that the sample is from a population of songs with the mean greater than 210 seconds. So, we'll be using this step. First, I want you guys to look at the original claim. Find the claim statement in this question. So, the claim statement should be the last sentence here. Test the claim that the sample is from a population of songs with mean greater than 210 seconds. So, in the claim statement, you could know which population parameter we are working on it. We can work on population proportion, population mean, population standard deviation, or population variance. And this one, obviously we are working on the population mean. So first, just translate this sentence from English to mathematical equation. So that would be the mean greater than 210 seconds. Okay, then you need to decide which formula for the test statistic in here. Okay, they given the standard deviation here, but pay attention, this standard deviation is talking about the sample of 40. So this is the sample standard deviation. Okay, when sample standard deviation is given, we'll be using the t distribution. Okay, t distribution. So look at the formula. Find out the test statistic formula in here. You could find out this one, right? T distribution. So based on the formula, you know that we are looking for the n, the sample size n, sample mean, sample standard deviation, and also the population mean. One more time, this population mean with the sample mean here, this is talking about central limit theorem. Okay, but there's no difference between these two. Okay, both of them, they do have the same population mean. Okay, now I want you guys with the question one more time and figure out what is your sample size, what is your sample mean, sample standard deviation, and also the population mean. Okay, you should get 40, right? Sample size 40, and then sample mean will be 234.6. Sample standard deviation. Okay, for the population mean, you could just look at the original claim here. So this is a 210, this is going to be 210 also. Okay, now, can you guys figure out the hypothesis? What is your null hypothesis and the alternate hypothesis? Okay, this is gonna be my null and alternate hypothesis. One more time, strictly less than, this guy should be on your alternate hypothesis. And the null hypothesis and alternate hypothesis is always like a complementary. Okay, that will be take out everything. So less than or equal to, and this is gonna be greater than. Okay, decide which tail test you gotta work on it. Left tail, right tail, or two tail. Should be white tail, right? Because this is a greater than, so that will be white tail. Okay, now plug into this formula and use your calculator to see what is your test statistic. Okay, and make sure this one, put the frequency on the top, put the frequency on the bottom. So you could get 2.70 here. Okay, now the distribution. So we are working on the t distribution. It looks like the bell shape, and also we have the white tail test. So you should have the bell shape here with the white tail. And then we are working on the p-value method. So the test statistic is 2.7. It's talking about like this point here. Okay, this point will be 2.7. And we'll be using the test statistic to find the area of the white tail, which is gonna be your p-value. Okay, and then we'll be using the TCDF. Okay, every time when you guys working on the p-value method, if you're using the z distribution, that will be the normal CDF. We are working on the t distribution, so this is going to be TCDF. And then the lower value will be 2.7, upper value will be 1E99. Okay, it's always look at it from the left to the right. And then you need to add the degree of freedom. Okay, degree of freedom will be n minus 1. So that will be 40 minus 1, which is going to be equal to 30. So now I want you guys use your calculator. Use the second bars, find your TCDF. And then find out what is your p-value here. You should get 0.0051. Okay, this is how you guys finding the p-value. Okay, one more time. Lower value, upper value, and then degree of freedom. Okay, the conclusion here. So after we got the p-value, we want to compare with your significance level. So significance level is going to be given 0.05 here. So we're going to compare these two numbers from the left to the right, point by point. So 0, 0, 0, and 5 here. So 0 less than or equal to 5. When your p-value is less than or equal to the significance level, that will be reject. Okay, final words, final conclusion. So remember we have the chart in the section 8.1. We call that a 1, 2, 3, 4 conclusion. So one more time, look at the original claim. This is a strictly greater than, so that will be go to your alternate hypothesis. Okay, they're exactly the same thing. So either using the conclusion number 3 or using the conclusion number 4. Then we have the reject, right? So that will be the conclusion number 3. So that is sufficient evidence to support the claim that the sample is from a population of songs with the mean length greater than 210 seconds. Okay, make sure you guys give me the complete sentence on the homework and also the midterm. Okay, next example. So I want you guys try to do it by yourself. Okay, just follow my rule, find out the claim statement, write down the original claim, decide which test statistic formula you're gonna use. And then based on the formula, you know what you are looking for the step 1 in here. Okay, first, find out your claim statement. Which sentence that will be your claim statement? It should be the first sentence here, right? And industrial companies claims that the mean pH level of the water in a nearby river is 6.8. So this first sentence will be your claim statement. And which population parameter we are working on it? Either proportion, mean, standard deviation, or variance. So we are working on the mean here. Okay, so mean is 6.8. So that will be your original claim. Then look for your formula. Which formula you're gonna use for the test statistic? You'll be using this one, right? Because they given the sample standard deviation. Okay, S is given will be the t distribution. Then based on the formula, you need to figure out these 4 guys. So you should have a sample size equal to 19, sample mean, sample standard deviation, and then the population mean, that's always equal to the original claim in here, which is going to be 6.8. Okay, now figure out what is your hypothesis. You have an equal and not equal to, right? Okay, which tail test you're working on it? Left tail, right tail, or two tail? Two tail, right? Okay, now plug in this number onto your formula here and use your calculator. Tell me what you guys get for the test statistic. Okay, one more time. On the top, when you guys using your calculator, put the parenthesis. On the bottom here also, parenthesis here. You should get negative 1.816. Okay, number 5, distribution. So we're gonna sketch, we have the bell shape here, and then we have two tails, okay? So two tails. So we have the test statistic is negative. So we have the numbers in here. And then we're gonna use the test statistic to find the area, okay, for both tail here. But first, we're gonna use the test statistic to find out the area to the left, and then we're gonna multiply by 2 because you have the two tail. So again, you'll be using the TCDF, lower value negative 1.99, upper value negative 1.816. Degree of freedom, that will be n minus 1, so that will be 18. Okay, make sure you multiply by 2 because you have two tails. Okay, you should get this one. And then conclusion. So you're gonna use your p-value compare with your significance level. Okay, so x is gonna be greater than 5. So that will be fail to reject. Okay, fail to reject. Okay, conclusion. So again, your original claim Sam has the null hypothesis. So it should be conclusion number 1 or conclusion number 2. Then you have a fail to reject. So that will be the number 2 conclusion. Okay, performing a hypothesis test for a mean using the critical value method. Okay, one more time. We are working on the population mean and S is given, but this time we'll be using the critical value method. So we still have the X step. It's just like the order is a little bit different in from here. Okay, you need to do number 4, 5, and 7. Other than that, they'll be exactly as same as your p-value method. Okay, we covered this part already. Okay, 1, 2, 3, 6. That's exactly as same as your p-value method. So number 4, the distribution. For example, we are working on the left tail example. Okay, left tail. And this is the critical value method. And we call the left tail here, this is called the critical region. Okay, critical region. And will be equal to your alpha. Remember, the significance level is always given, right? So alpha will be equal to the area of the left tail. If you are working on the right tail, so your alpha will be equal to the area of the right tail. If you are working on two tails, then you need to divide that by 2 for the significance level, okay? So we're gonna use the area of the left tail to find your critical value. Okay, this point that will become your critical values. Again, we'll be using the t distribution. So for the critical value, you'll be using the inverse t. Okay, inverse t. So inverse t, you could find it from second, and then vast. You should find the inverse t. But this inverse t, you only can find it on your TI-84 PASS calculator. If you are using TI-83 PASS calculator, you need to do the programming, okay? You could look for the YouTube video, or you could see me after class. I could help you do the programming. Okay, inverse t, plug in area from the left, which is gonna be your alpha here, and then the degree of freedom. Degree of freedom, that will be n minus 1. Okay, and also, when you have a left tail, you will have the negative critical values. If you have the right tail, then your critical values will be positive. But if you have a two tails, then you will have a two critical values, and that will be plus minus. Okay? Okay, after you find the critical values, you will have the test statistic, all right? The test statistic, look at it, find it out from this picture here. Where is your test statistic located? If your test statistic is in the critical region is talking about like this part, then that will be reject. If your test statistic is not in the critical region, means like here, that will be fail to reject. Okay, conclusion, same idea. 1, 2, 3, 4 conclusion. Okay, let's try this example. We will be using the same example from the p-value method. So on the notes, I should give you guys all these things already. Okay. So look at it, you could see the critical value. So I want you guys using the critical value method. Okay, we are using the t distribution. So we will have the picture as a bell shape. And then that's a y tail. Okay, remember what is the area of the y tail? It should be equal to your significance level, okay, which is gonna be your alpha. So we will use the alpha to find the critical values. And since this is the y tail, so we only have a one critical value, and it will be positive. Now, let's figure out what is the area from the left here. So total area is 1 minus 0.05, which is going to be 0.95 here. Okay, then find your critical values. We'll be using the inverse t, area from the left, and also the degree of freedom. Okay, degree of freedom, 39. So use the calculator. You should get this one. So here, this point, that will be the critical values equal to 1.685 here. Now, we're gonna figure out what is our test statistic. Okay, you should get like 2.7. So now, look at the test statistic. Where is your test statistic located? Should be in the critical region or is not in the critical region. So 2.7 will be here. Okay, so this is gonna be in the critical region. When the test statistic is within the critical region, will be reject. Okay, reject the null hypothesis. Okay, again, conclusion, that will be number 3 conclusion. Okay, number 3 conclusion. Okay, number 6. So again, we covered this part already, right? So we will have the distribution, the bell shape, and we have a two tails. And then, remember what is the area of these two tails? That will be equal to 0.05. okay, 0.05. So make sure you're gonna divide it by 2, find out the area of each tail. So this is divided by 2, you should get 0.025 here, 0.025 in here. And now we have a 2 tails, so we have a 2 critical values. And since this is a symmetric, right, so we should be plus minus. So now, first find out the critical values to the left in here. So that will be inverse t, again area from the left, that will be 0.025. And then the degree of freedom, n minus 1, so which is going to be 18. You should get negative 2.101. Okay, and again, we have a 2 tails, so we have a 2 critical values. That will be plus minus in here. Okay, your test statistic. Negative 1.816. So look at it, this test statistic is located in the critical region or is not in the critical region. So should be here, right? So this is not in the critical region. So we will fail to reject, okay? Fail to reject. And then conclusion, that will be either number 1 and number 2. And fail to reject, so that will be number 2 conclusion. Okay, part 2, performing a hypothesis testing for a mean using the p-value method. And this time, population standard deviation is given. Okay, remember the first part, we are working on the hypothesis testing for the population mean, but S is given, sample standard deviation is given. Then we'll be using the t distribution. But here, they given the population standard deviation, so we're going to be go back using the z distribution. Okay, so same idea, we are working on the mean, find out the formula, the test statistic formula. So should be the z, so we are working on the z distribution. Figure out these 4 guys here. Look at here, this is a population standard deviation, okay? And then figure out your alternate hypothesis, know an alternate hypothesis, and decide which tail is gonna be. Okay, p-value method. So let's say we have the left tail example. Then this point here, that will be your test statistic. Okay, that's test statistic. Use the test statistic to find the area from the left, which is gonna be your p-value. Okay, every time when you're using the p-value method, that will be the CDF. This is the Z, so that will be the normal CDF. Okay, lower value and upper value. After you find the p-value, compare with your significance level. And then use 1, 2, 3, 4 conclusion. Okay, you can see it's really similar. Okay, similar to the proportion. It's just we are working on the mean and we have a different formula. Okay, you could use your calculator to double check your answer. Okay, let's try this example. Okay, they're gonna give you a list of the data. This is my data set. And then they also give you the population standard deviation. Okay, so with the claim statement, test the claim that the cell phones have a mean radiation level that is less than 1. Okay, so the mean radiation, we are working on the population mean and they given the population standard deviation. So we will be using the z distribution. So first, find out the original claim. That will be the mean less than 1 in here. And then find out the formula for the test statistic. Then figure out these 4 guys. Okay, n means like the sample size, right? So we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have the 11 data here. The mean, you should know how to do it, right? You could use your calculator, plug in this data to your L1, and then go to the stat, go to the cal, and one variable statistic, find out the mean. And since they given the population standard deviation, we'll be using this one instead of using the sample standard deviation. Population mean will be the same with this guy here. Okay, now figure out your null and alternate hypothesis. And that will be the left tail here. Okay, now figure out your test statistic. Plug it in. You should get this one. Okay, one more time. Parenthesis here on the top, parenthesis here on the bottom. Okay, left tail example. So we have the test statistic. It's a negative 0.43, right? So use the test statistic to find the area. So that will be normal CDF, lower value, upper value. You should get this guy. Now compare this number with your significance level. So which is going to be greater than, right? So fail to reject. Okay, final conclusion. So original claim has same as the alternate hypothesis. So that will be number 3 and number 4 conclusion. And then we have a fail to reject. So that will be the number 4 conclusion. Okay, that's it.